All right. So first of all, our book has a bunch of investigations in GeoGebra that you could use to try to figure this stuff out on your own. We're not going to take a ton of time. I don't have a chance to get a laptops or get the iPads in here, but I do want to help show you that this is going to happen no matter what. So first of all, we want to know what's going to happen to a perpendicular bisector of a chord. So if we look at GeoGebra and we have this example or this investigation, first of all, what's the name of my chord? Chord CB, or segment CB, right? So CB is a chord. And they want us to find the perpendicular bisector of that chord. So this is the tool that we use to find a perpendicular bisector. And the neat thing about it is all I have to do is press on the red chord and we get the perpendicular bisector. Okay? Now, as I drag it around, what do you notice is happening with that perpendicular bisector? It goes through the center, okay? So no matter what we do, you okay? So no matter which way we drag it, I think she's okay. She's going to take a drink and she'll be fine. Okay, so no matter what we do, it's going to be through the center of that circle, okay? So if I had 2 points on this, let's go ahead and put 2 points where these guys intersect. A point of intersection. So this one and this one are places where that perpendicular bisector intersects a circle. What special chord is DE? Segment DE. A diameter, and it's going to make a semicircle. Exactly. So ED is a diameter, and that diameter is perpendicular bisector to the other chord. Okay, so that's one quick investigation. Let's look at another one. All right, so now we have a perpendicular bisector to a diameter. Okay, so we're going to look at this one real fast. All right, so we had a diameter here, and DE is now the perpendicular bisector of that diameter. So as I move things around, see how it has to cut the diameter in exactly 2 equal parts? Or actually, the diameter cuts the chord into 2 equal parts. Okay? And if I measure things, they give me the ability to measure. We want to measure this segment. It's 2.34. We measure this segment, and it's also 2.34. So as I move things around, it will become larger, but it's always going to split that chord into 2 equal parts. Okay? All right, so onward and forward. So in a circle, here's one of our theorems. In a circle or in 2 congruent circles, 2 circles that have the same length for their radius, chords are congruent if and only if their corresponding arcs are congruent. Okay? So chords are congruent if and only if their corresponding arcs are congruent. Jenny, if you're working on your assignment, you don't have to put your phone away. You're fine. Okay? So chords are congruent if and only if their corresponding arcs are congruent. And corresponding arcs are congruent if and only if their chords are congruent. So when I know that chord DE is equal to chord CB, then I know minor arc CB is congruent to minor arc DE, and vice versa. Make sense? Okay, let's apply it. So they're asking us to find the measure of arc DE. And it's a minor arc, only has two letters, so it has to be under 180. So from D to E, we want to know how big that arc is. What is the measure of that arc? Okay, and Jaden's already come up with the answer. Give you a chance to process. So we know that there's an arc that's 30 degrees, right? How much is left for the rest of the circle? 330. Everyone see why? 360 in the whole circle, 30's used up. And Jaden said that arc DE has a measure of 110. How did he find that? And why would you take 330 divided by 3? Because there are 3 arcs that are all equal, aren't they? So it's 110. So 360 minus that 30 gave us 330 for the remaining arcs. And because these are congruent segments, congruent chords, that makes the arcs have to be congruent. So 330 divided by 3 is 110 degrees. Easy peasy? Lemon squeezy. All right. Now, our second theorem was a conjecture that we made. It says that if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and it also bisects its arc. Okay? So, first of all, we want to decide what is the distance between G and I. Okay? So, does everybody agree with 14? Why is it 14? We see it's perpendicular, right? And it goes through the center. So this diameter is a perpendicular bisector of this chord. So these two have to be equal. GI will be 14. Make sense? Okay, now we also want to know the measure of major arc, GJH. Okay, so major arc GJH says start at G, go through J, and come over here to H. So how will we find that? So 80 minus x equals 9x. Why does 80 minus x have to equal 9x? Good. Since that chord was bisected, the arcs have to be that arc has to be bisected. So what is x? And x equals 80, so x has to be. And now that we know that x is 8, 80 minus 8 is, and 9 times 8 is, okay. So that minor arc, GH, has a measure of 144. How does that help us find the major arc, GJH? Absolutely. You're naturals at this. 216. Pretty good. Okay. If a chord is a perpendicular bisector of another chord, that first chord has to be a diameter. We saw that in our investigation. Really quick investigation, but it should help us to figure out the distance between K and H. So if we want to find the distance, the length of chord KH, how do we do that? 14 times 2 or 14 plus 14? Everybody agree it's 28? Okay. N is not a center. Yes, M is a center. N is, yes, supposed to be the point where those two. And M is the center of the circle. And so that's why we know that JL is the perpendicular bisector because it is a diameter. Okay, very good. And then we want to be able to figure out the measure of major arc HLK. So H to L to K goes this way, starting at H, passing through L, ending at K. So how are we going to find that? Good. So let's add x to get the x's on one side. 135 equals 3x. What's x? We get 45. Okay. How does that help us? Plug it in. So 90 minus 48 is 82. 2 times that 45 that we just found. Trying to add and write different numbers at the same time. So 90 minus 8 is 82. So 82 for that minor arc. 82 for the other. So 164 for the arc HK. And 360 minus 164. HLK. If our mental math is correct. Okay. Where did I get what? I'm sorry. Figure it out. Any other questions on this one? Okay. So, next example. This is a map of Google Map from my area of the woods where I grew up. Okay. So I grew up near Crofton, Nebraska. My dad's farm is about almost directly south about here. Okay. And at my dad's farm, it has horrible cell service. It doesn't matter if we have Verizon, Sprint, AT&T, because it's not a very big populous area. And so therefore they don't have enough towers necessarily. It's not cost effective to put those towers out there. But let's pretend that to avoid me having to go to the top of the hill when I want to make a phone call, right? I can get text messages, but phone calls are a different story. Let's pretend that they decide to put a cell tower equally spaced between Hardington, another town near Crofton, and Bloomfield, a third town near Crofton. We want to find a center of a circle that encompasses those three towns, is what we're basically doing. An evenly spaced cell tower from all three places. So what should we do? We got to figure out what the center is, right? If we want to draw a circle. So we think the circle is going to look something like this, right? But we don't know for sure where that center would be. But what if we found the chords between those towns? Here's a chord of that circle that we don't know where it's at yet. And here's another chord, right? And we could make a third chord between Bloomfield and Hardington. And figure out the perpendicular bisectors of those three chords, right? Because what happens at the perpendicular bisector? It ends up being a diameter, doesn't it? And where the two diameters meet should be the center of the circle. Does that make sense? Okay. If I've done this well. I think I actually had constructed a circle around it. I did a pretty decent job. Blast from the past. What do you think that center is called? The centroid. Not the orthocenter, the C. Circumcenter. Someone was probably saying, you were saying it, I just didn't hear it, I'm sorry. Yes, this is the circumcenter of that triangle. So it's going to help us find a point that is equidistant from all three points, all three towns. Okay? Questions on this one? All right. This is your last slide, last example. In the same circle or in two congruent circles, two circles with the same size radius, we two chords are going to be congruent if and only if they're the same distance away from the center. Okay? So in this circle, this does not look like it because of the skewing of our projector with the different size dimensions of the smartboard versus the laptop. But if these two distances are congruent, that means that these two chords have to be congruent. Okay? So what are we going to do to figure out what x is? Yep. So we set the two chords equal to each other. Sorry, thank you. And we're going to take the 5x from both sides and add 3 to both sides. So x is 5. And we plug it back in. 7 times 5. So 35 minus 3. So if that's 32, this had better be 32. So they're asking us to find the radius of circle E. So here's where we have to do something special. Because we want the radius of circle E. Remind me, what's a radius? Half the diameter has to go through the center to a point on the circle, right? So I'm going to pick this one. It doesn't have to be D. I could have picked B to draw 2 from E. And so this is a radius. We're trying to find this radius. So EP. Yes, we're going to use either EP or EQ in this, right? So I could draw this radius or this radius. It doesn't matter which one I draw. Okay? So here's my R, and I know that this whole side is 32. So how much is this piece from C to Q? 16. And I know that this distance here was 12. And I have a right triangle because through the this is the bisector of this perpendicular bisector of this chord. So what would I use to figure out what R is? Pythagorean theorem. Okay, we used it a lot last chapter. We'll use it some this chapter as well. So my hypotenuse is which one? So we want the R squared to be by itself. And what's 12 squared? And what's 16 squared? So you don't have to write R squared equals 12 squared plus 16 squared. You can simply start squaring them out. What's 144 plus 256? So 400 equals R squared. What's R? So R is 20. And we ignored the fact that it could be negative 20 because it doesn't make sense to have a negative radius. Okay? Your assignment's on the bottom of your sheet. It's also here. And if you started early, you're probably halfway through it already.